Okay, this is the 8th video installment in the Math I EOC release test that I'm working through. We're going to start with number 45. The sequence below shows the total number of days Francisco had used his gym membership at the end of weeks 1, 2, 3, and 4. And then it says the number of days he used it. Assuming the pattern continued, which function could be used to find the total number of days Francisco had used his gym membership at the end of week N? So again, we're looking to find an equation, and we're going to write it in the format of y equals mx plus b. The easiest thing to do in this case is to make a table. Okay, so you have weeks, and then you have the number of days that he used the gym during those weeks. Okay, so week 1, 2, 3, and 4. In the first week, he used it 4 days, and then 9, 14, and 19. Okay, so in order to get slope, we've talked about several times how slope is the change in y over the change in x. So let's look at the y values and see how they've changed. So if you'll notice, each time they increase by 5. On the x values, each time they increase by 1. So to get our slope, the change in y is 5 and the change in x is 1. So our slope is going to be 5. To get our y-intercept, we know that the y-intercept is whatever y is when x is 0. So if we go and look at our x values, if we go backwards and we get 0, and then go backwards here on the y, we're going to end up at -1. So when x is 0, y is -1. So that would be our y-intercept. So our equation then would be y equals 5x minus 1. Written in the variable form that they give us, we would do f of n equals 5n minus 1. Okay, so that's how you would solve it if you wanted to do it by hand. On the next slide, so I'm also going to show you in the calculator how you could have done this problem. You could go to the table and list all your x values in the first column, all your y values in the y column, then go to Stat, scroll right to Calc, and select number 4. And then it would give you the equation for you. So again, you have your slope of 5 and your y-intercept of -1. Okay, number 46. The volume of a sphere is 2,400 cubic centimeters. What is the approximate diameter of the sphere? And then they give us the formula. All right, so we have volume equals 4/3 pi r cubed. And then they give us the volume. So I'm going to plug that in for V. Okay, so now what I can do is solve for r, which is the radius. And then once I have the radius, I know that 2 times the radius equals the diameter. And the question says, what's the diameter? Okay. So here I'm just going to solve for r. So the first thing that I would do is to get rid of 4/3. Whenever you have a fraction that you want to get rid of, you can multiply both sides by the reciprocal of that fraction. That means that you're taking the fraction and flipping it over and multiplying both sides. Okay, when you do that, it cancels out that fraction. All right, and that gives you 1,800 equals pi times r cubed. Again, we're trying to get r by itself. Pi is just like any other number or coefficient in front, so we're going to divide both sides by pi. All right, so that will give us 572.96 equals r cubed. The opposite of cubing something is taking the cube root. So I'm going to take the cube root of both sides, and that will cancel out the r cubed and just give me r. So my calculator, to get the cube, I go to math. And then if you look down at number 4 right here, you have the cube root. So I'm going to do the cube root of 572.96. All right, so r is going to give me 8.31. Now, if you're not careful, if you look, you're going to see this answer and be tempted to pick C. Okay, but they did not ask for the radius, they asked for the diameter. So I need to take my radius and multiply it by 2 to get the diameter. And so the correct answer for the diameter would be somewhere around 16.61 centimeters. And so that would be answer choice A. All right, 47. The number of points scored by a basketball player in the first 8 games of the season are shown below. What would happen to the data distribution if she scored the following in her next 4 games? So if you notice, all of the answers are talking about something being peaked and spread. Okay, when we're talking about something being peaked, that's talking about the mean. Okay, because basically, when we put these scores in, they're going to form a sort of data distribution. If it becomes more peaked, that means that we're going to have a higher curve. Less peaked is having a lower curve. Okay, so if it's more peaked, that means that the mean has increased. If it's less peaked, that means that the mean has decreased. Okay, talking about spread, that's how wide the data distribution is. So maybe it looks like this, or maybe it looks something a little more spread out like that. Okay, spread is specifically talking about standard deviation. So if something has more spread, then the standard deviation has increased. If something has less spread, then the standard deviation has decreased. So what we're going to do is in our calculator, we're going to enter in our data into our lists. I'm going to clear out what I have here. So I'm going to enter in the original data, which is given at the beginning of the problem. Then I'm going to calculate these statistics for that data. Then I'll go back and enter in the additional data that they gave and calculate the statistics again. And then we'll be able to compare the mean and the standard deviation and see what happened. So this is the original data. In order to find the mean and the standard deviation, I can go to Stat, scroll right to Calc, and select number 1. The mean is right here, the X with the bar over it. So originally, with the original information, the mean is 24. Standard deviation is the S with the X next to it, so that's 7.67. Okay, so that's with the original information. Now I'm going to go back to Stat and Edit, scroll to the bottom of my list, and I'm going to enter in the additional data that they gave me. Okay, and at this point I will recalculate, so I'll go to Stat, Calc, and select number 1. Alright, my new mean is 24.42. My new standard deviation is 6.32. Alright, so if I look here at my data, the mean has increased, okay, and the standard deviation has decreased. So that means that my data should be more peaked and less spread. And that would be C, more peaked and less spread. Okay, number 48. The table below shows the shoe size and age of 7 boys. And then we have our information. Approximately what % of the boys' ages is more than 1 year different than the age predicted by the line of best fit for the data? So what we're going to do is find the line of best fit for the data in our calculator. And then we're going to look at the predictions for each of the shoe sizes and the ages and see how they differ. So again, we're going to go back into Stat, edit, and clear out anything you have. And then you're going to enter in the first column of data into list 1. And the second column of data into list 2. Okay, now we're looking for the line of best fit, and the way that we find that is to go to Stat, scroll right to Calc, and select number 4, Lin Reg. All right, and then we're going to use that and write our line of best fit. So y equals 1.13 x plus 4 point. Now the 7 here makes this round up, which makes that round up to 4.1. Okay, so in my y equals, well, now that I have the equation, I need to be able to look at a table to see the predictions based on shoe size and age. So in order to do that, I need to go to y equals and type in my equation. And then I'm going to pull up the table. Okay, so once I type that in, I'm going to press second and then graph, and I have my table. Over here in the X, this is the shoe sizes, and on the right, that's the ages. So for example, this says 1. So at 1, year 1, if your shoe size is 1, then you should be about this age. If your shoe size is 3, you should be about 7.5, so on and so forth. So we're going to scroll down because if you look at our chart over here, the shoe size starts at about 6. Okay, so at 6, it says that the age should be about 10.8. We're going to mark the ones that are more than 1 year different from the age predicted here. So, okay, so here it says 10.8, and this student or this child is 9. That is more than 1 year different. So we're going to put a check next to them because we're counting the ones that are more than 1 year different. Okay, Marcel is 11, and that's not more than 1 year different than the predicted age for him. Okay, let's scroll down to 7 and look at Patrick. Patrick should be somewhere around 12. And he's not, so he's more than 1 year different, so we're going to mark him. Bobby, who is 8, should be somewhere around 13. He's more than a year different, so we're going to mark him. All right, and we're going to look at Dylan, Mike, and Jonathan, who are 9, 10, and 11 for their shoe size. Okay, for Dylan, he should be around 14.2, which, yep, he's within that range. For Mike, he should be around 15, and he's within 1 of that one. And Jonathan is also within 1 of that one. So total out of 1, 2, 3, 4, 5, 6, 7 children, 3 of them are more than 1 year different. If you look at your answer choices, they're in percentages. So we're going to take our 3 that are different out of the total of 7 and figure out what the percentage is for that. So 3 out of 7 would give us 0.428 multiplied by 100 to get a percent. Okay, so that's somewhere around 42.86%. All right, it says approximate, and so our closest would be C, 43%. All right, number 49. The scatter plot below shows the number of arithmetic errors 10 students made on a quiz, and then the amount of time it took for the students to complete the quiz. And the question asks, what kind of relationship is there between the variables? So how are they correlated? What's the connection? If you look at the dots, if you were to draw a line that would kind of fit where the dots are spread, it would look something like this, okay? Give or take a few spaces. So this obviously it has a negative slope, so we can go ahead and cross out the ones that say positive. So that's A and C. And now we have to decide if we think it is a strong or a weak correlation. A weak relationship would look a little bit more like this, okay? And a stronger relationship would look a little bit more like that. Here, I'm sensing that this is probably closer to a strong relationship. So I would select B, strong negative. All right, and our last question on the release test. An elevator can hold a maximum of 1,500 pounds. 8 people need to use the elevator. Bill had some measures from the data set of how much each person weighed. Which measure would be the most useful? So when we talk about, if you think about like your friend or maybe even you, and you think about one word that would best describe you, that's kind of like picking one piece of, or one central tendency to best describe a data set. So for example, if you have a data set that is pretty small, okay, so a small data set, or the numbers are really close together, then you would select the mean. Okay, for median, you would always use the median if you have an outlier. That means that a number that's very, very different than the others. So for example, on a test, maybe everybody in the class made somewhere around an 80 or a 90, and then you have one student who made like a 12%. That would be an outlier. You want to use the mode when you have a lot of numbers that are the exact same. Okay, and standard, or the last one, interquartile range, does not really fit because we typically only use mean, median, and mode when discussing measures of central tendency. So you can go ahead and mark out D. So if you look at your question, it doesn't give you any information that you have an outlier or something that stands out from the other packages. So I would cross out, or people. So I would cross out B. It does tell you that you only have 8 people. That's actually a pretty small data set, so that would make me lean more towards mean. You also don't have any information that these people are the exact same weight, so I would cross out C as well. This is kind of a confusing and tough question, but at this point I think the best answer that we could choose would be A.